Okay, well, welcome back. We're going to continue our instruction on applications of law and cosines. And what we have right here is we have an application about the good old sport of baseball. Take me out to the ball game. Take me out to the crowd. Buy me some peanuts and cracker jack. If you don't like that, well, let's just get back to the problem. All right. Hope you enjoyed that song. But I love baseball, and the good old problem of baseball, yes, also applies with triangles. So let's check this out. It says the baseball player is in center field and is playing approximately 330 feet from the television camera. So I'm going to draw a little picture because that's what I do. All right. Sometimes you're given your book, you see the figure. I didn't draw up here because you need practice drawing the picture. So if you want to beat me to drawing the picture, you can pause this and draw it, see if it looks like mine. Probably won't because I draw very poorly. All right, so I'm going to draw a stadium here. All right there. I'm from Milwaukee, so got some Miller Park action going on here. But in any case, we have a television camera, which is going to be right behind home plate. And we have the center fielder, and you can put the center fielder anywhere. All right, obviously, this is not to scale. If you've watched any of my other ones, I do not draw to scale. Just drawing a little sketch to help us figure out. So we know that this right here, this person is 330 feet away from the television camera. It says that a batter hits a ball that goes to the wall 420 feet from the camera. So what happens is this ball is hit and it's rocketed. All right, 420 feet to the wall. Approximate the number of feet that the center fielder has to run to make the catch if the camera is turning it at 8 degrees to follow the play. And so what's happening is that now this center fielder is going back, and trying to catch this ball. This angle of the camera is following it, and it's going at 8 degrees. And so we want to figure out how far did the center fielder have to travel. Well, if you look at this problem, what we create is, what do you know? A triangle. So we're going to figure out what this side of the triangle is, and unfortunately it is not a right triangle. It is an oblique triangle. So we have to use the law of cosines or the law of sines. Well, since we're given a side, we're given an angle in the middle of another side, side angle side, and we're asked to find another side, we're going to use the law of cosines to help us figure this out. To help us figure this out right here is since we are given the opposite, we're trying to find the opposite side of the angle given, we're going to say that x equals the square root, and if you know the law of cosines, should be 330 squared plus 420 squared, and that's going to be minus 2 times 330 times 420 times now the cosine of 8 degrees. Cosine of 8 degrees. All right. And so what we have, you put this in your calculator, and what you should get is a value of, all right, I put in mine, all right, 103.912 feet. Now, if you want to round to the nearest foot, it would be 104 feet. Okay, and that, my friends, is how far that center field had traveled. Pretty awesome. Yes, math and the law of cosines and law of sines can also be applied to baseball. All right, so I hope this makes sense. We're going to have another baseball example in just a little bit.